be doing as an exercise every class from here on out is we're going to be, I'm hoping every class, we're going to be looking at a released FRQ, which just FRQ just means free response question from a previous test on the AP exam. And the one that I selected for today is question number 1 from the 2013 exam, okay? And what I'm going to show you first, and I've had given you about 10 minutes, and the reason I gave you 10 minutes is because that's approximately the amount of time you want to spend on each FRQ. There are a total of 6 questions in the free response section. 5 of them are all this short, and then there's the last questions called an investigative task. It counts a little bit more than the others, and it's a little bit longer than the others, so you want to give yourself about 20 minutes on that particular question, okay? So questions 1 through 5, about 10 minutes apiece, and then the last question about 20 minutes apiece. You have an hour and a half to complete the second section of the test. Fair enough? And I'm saying approximately because you're going to, 5 minutes more here or less or whatever. That's a general rule of thumb. So on all questions 1 through 5, when we do them in class, we will spend 10 minutes on them to kind of get you used to about that's how much you will spend. Some of them will be longer, some of them will be shorter. This one would actually probably take you less than 10 minutes, I would think. Okay, but let's go ahead and look at the grading rubric for this particular question. What was the graders looking for, and how would points be assessed? So I brought up the College Board's website, and I'm just not going to sign in or anything. I'm just going to go to where I found this information so you can practice it and find these things at home as well. This goes for any AP class for that matter. If you click on the AP tab at the top, and again, I just went to collegeboard.org. That's all I did. I didn't log in as a student. I didn't do anything. And then if you click on AP Central is where all of the AP curricula, release tests, all that kind of stuff is housed. There's all kinds of information about what should you bring on the test, what should we do, etc. But we're going to go ahead and look at AP courses and exams, and we're going to look at specifically the course homepage. I think it's course homepages. It might be real. Hang on. I always get confused. It's either here or I think it's AP statistics from here. Nope, that's not it. It's not course homepages. It is the exam information, I think. There we go. Let me go to AP stats. And they should be listed down there. There they are. So it's exam information, not course homepages, okay, for AP stats. And it talks a little bit about the release questions. We've been giving this exam since 1997 in this country, actually all over the world since 1997. So it's one of the newer AP exams that exists out there, which just means there's not as much released information. There are new free response questions every year. So there's nothing that's ever been recycled in terms of free response questions. So you won't ever see this exact question that you did again. But what we can practice is the type of question, how to answer them, that kind of thing. There's only been a couple of release multiple choice portions. They do tend to sometimes recycle those, so there's not been many that have been released. They're a little harder to write, quite frankly. And I do have some practices, and we'll look at some of those as we get closer. But all year long, we've been kind of practicing the multiple choice questions, right? Every test has had that. But anyway, here we are in the AP content. It does say about 10 minutes each if you read on the FRQ. It kind of goes through everything. Multiple choice questions. There are 40 that you have an hour and a half to answer, etc. So here are all the free response questions that have been indexed. And again, half of your score is multiple choice and half of your score is free response. Multiple choice, we can't really do a whole lot other than talk about strategies of when I should guess versus when I shouldn't guess and that kind of thing, and we'll talk more about that as the exam gets closer. But today and for the next couple of class periods, we're going to look at some free response stuff, okay? So which year was it, 2013? Is that what I gave you? So if I click on 2013, I scroll down, it's one of the first ones. Like I said, I'm sure I've told you, but I graded the 2014 exam, so I know that exam pretty well. We'll look at a couple of those questions probably next week or after spring break. But I went ahead and looked at one from 2013, which is not one that I graded. So that just means I'm not as familiar with the grading rubric. So kind of like we'll learn this together, so to speak. We will look at what they were looking for, how you would get points, how points would be deducted, that kind of thing. Okay? So if you look at 2013 in this grid here, there's all different kinds of things that are available to us. I'm not sure whose backpack this is, but it's going in the chair, so I don't kill myself. If you look there, it's kind of hard to see because it's small, and I get that. But the actual questions, I can click on here, and this would be a PDF that would bring up the 6 questions, the 5 FRQs, and the 1 investigative task. The scoring guidelines is what we're going to be looking at specifically because we're going to look at how they graded it. And then you can actually look at some sample responses as well. They will also give you the distribution, meaning how many 1s, 2s, 3s, 4s, and 5s are given on the exam. Okay? So we'll look at that, or that particular question. But for now, we're going to look at the scoring guidelines. Okay? And so this is what is released by, I want to make it a little bit bigger. This is released by AP and how the actual exam was graded. So it just talks about the College Board. Yay for the College Board. Here's question 1. Okay? Now, each portion of the question, or each question, so there's 1, 2, 3, 4, and 5 questions, or 6 if you count the investigative task. Each question is given a score, but it's based on what's called an E, a P, and an I. Okay? And if you take AP Comparative Politics or any other AP course, hopefully we've talked about that. E stands for is essentially correct, P stands for partially correct, and I stands for totally incorrect. So your goal is to get as many E's as you can, okay? And you'll normally questions have parts 1 and 2, or maybe A, B, C, D. This particular question only had parts A and B. Do you agree? Okay? So we're going to hopefully get E's on both. That will give us the maximum score that I can get on this question. Okay? You can get, and then we'll look at the end where it can talk about what if you get an E and a P, or a P and a P, and E, whatever. We'll look at all those different combinations. All right, so this question talked about crows, okay? And we can kind of look at the intent of the question. It was the primary goal was basically could you use a stem and leaf plot to answer a question about a distribution? And 2, can you identify and compute an appropriate confidence interval after checking necessary conditions? As I walked around, I bet you most of you didn't check the conditions. Did you? That's part of the grading rubric, which means you've automatically taken yourself out of the essential on that. You've already started with the P. I'm telling you, if you don't have the conditions checked, they're not going to give it to you. Okay, well, let's see how many we get. Okay, let's look through it. And then the last thing is to interpret the interval in the context. All things we've been doing all year long, right? Making sure that we can find it using the formulas, making sure we can interpret it in context. All things they're looking for. So for part A, and I love Daniel's question, he asked me, he said, how many decimal places should we round? As a grader, for part A, all you had to write was 4 out of 23. And if you wrote only that, you got an essential on part A. Okay, that's all you had to do. How many of us got that? The whole class. Woo, 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 because Evie's sleeping, and that's all right. You got a 4 out of 23? Okay, yeah, she did. So everybody, woo! All right. So that's great. Okay. For part B, trying to make it not go. Hang on. I don't know why it doesn't want to do this. I hate PDFs on here. All right. Well, no. Sorry, guys. Come on. Whatever. All right. So part B, down here, there's going to be some steps, and each of the steps are going to be asking us to look at specifically, and I'll show you in the grading portion of that, what they're going to be, how they would assess that, okay? So for step 1, it says to identify the appropriate confidence interval by name or formula. What that means is you had to say 1 proportion interval, or 1 proportion z interval, and then you could find it, or you had to use the formula and give me an answer, okay? So that's part of their grading rubric. That's what they're looking for. Kind of like name the test, name the interval. So it's something we need to practice doing. Again, if you just use the formula, not plugging the numbers in, but told me p hat plus or minus z star and use the appropriate formula, that would be enough. Okay? That would be enough. But not with the numbers plugged in. Okay? So either the formula or the name was what they were looking for. All right, so let me I got to scroll down from my computer because it doesn't like me doing it from up there. It is a one sample t interval because we are talking about means. I think I said z earlier. I apologize. We are talking about means. Okay. What was the averages we were looking for, by the way? I don't have the thing in front of me. Something about crows. What was it? What were we looking for? The average what? Lead level. Okay. Thinking about context we're talking about. All right. There were two conditions for a t interval. Randomly selection. Does it say that it was randomly selected? I think it does. And we have to check the nearly normal condition. Okay. The nearly normal condition. Notice what condition they're missing. The sample size is less than 10% of the population, right? They didn't even ask to check that. If you did, that's great. But you had to check for both of these. Interesting. Nearly normal, or the sample size is large. Okay. Is the sample size large enough here? Is 23 big enough? No. Okay. It's in that middle range, isn't it? Where if it's smaller than 15, then we're not sure. We have to proceed with caution anyway. If it's between 15 and 30, we're going to check the histogram or check the normal probability plot and see if the data is normal. And if it's greater than 30, we don't care because it's large enough. Right? That's kind of like that third condition for the condition for means. All right, so it says the first condition is met because we were told that the crows were randomly selected. The sample size of 23 is not large, so we have to examine the data. But notice what's given. We don't have to really look at a histogram because what are we given? What data display is given to us in the problem? So a stem and leaf plot, doesn't a stem and leaf plot show skewness? So if I just turn my stem and leaf plot sideways, can't I see if it's relatively normal or not? All you had to do was say that. If you say, according to the stem and leaf plot, the data looks relatively normal, you've met that condition. Okay? That's all you have to say. AP loves stem and leaf plots and dot plots because they do show shape. So they often give them to you. Okay? All right, let's keep going. So the correct mechanics for the interval, notice that this formula right here that I'm circling is enough to be able to say that you've identified the correct interval. Or you could have said one sample t interval is fine too. We have to talk about the degrees of freedom and find the correct t star. Okay, the t star with 22 degrees of freedom was 2.074. Did you guys find the correct t star value? The table's okay. They have the tables on you for the exam. I'll double check that, but I'm almost positive. You could have done inverse t, right? Inverse t, question?
So if I have like 2.0738 and I didn't round it up.
So that's a great question. Kind of like Daniel's question, how much do I round? 2.0738 is perfect. They're not going to make you round it to 3 decimal places. What they won't let you do is tell me it's 2. Okay? So 2.07 probably would have been acceptable as well. Okay? But definitely don't round it to a whole number. If you round it more, or round it whatever, it's going to be fine. All right, so we've shown the mechanics. Question, Isaiah. Well, let's look at the grading rubric. Let's see what they're counting. I'm not really sure. So let's look what they're looking for. Okay? I think on an AP exam, if you've taken less than 10 minutes on the question, you might want to write as much information down for that as you could. So I might say there are 22 degrees of freedom. T star is. Okay? Just to be as specific as possible. All right, how many of you actually got the correct interval? Okay, almost half of you. Good. All right, so interpreting the data, we can be 95% confident that the true population mean lead level among all crows is somewhere between 4.416 and 5.384 parts per million. Notice it's not a percentage here because we're talking about means. It is a confidence interval about means, so we use those correct units. Yes?
Won't the chart
on the chart. Which chart, baby? Oh, in the book? Yes, that's okay.
And so my answer was slightly different.
Yeah, that's okay as long as you were clear with what numbers went in where, you would get credit.
On the confidence interval, it says Z interval, the confidence interval.
We're not doing Z's. We're doing T's.
Well, it said for means and the populations.
We don't know the population standard deviation. We rarely ever know the population standard deviation for means. Like, there's no possible way for us to test every crow on Earth and decide what their mean their lead level is, right? So we would never know that. So because of that, we are going to use T procedures, not Z. Okay, and I would say almost always that happens. Almost, yes.
Okay, so when you have your confidence intervals, when you're like writing down in context, if you like round them in context,
That's okay too. That is okay too. All right, so based on that is the solution that is provided to us by AP. Now let's actually looking at the scoring guidelines. This is how you can assign yourself an E, a P, or an I, and how many points would I have gotten on this particular question. So let's go ahead and look at this. Is the scoring line. This is how it is scored. It says the question is scored in 4 sections. Interesting. There's only 2 parts. Okay, we don't know this until we show up for the day that we grade. We have no idea how they're grading these questions. They just kind of create this and tell us this information. So how are they? Section 1 is part A. Section 2 has section 2 of part B is step 1, step 2, and step 3. So I guess part B had 3 steps to it, right? Naming the test, or naming the interval, the mechanics of it, and interpreting, right? So those were kind of like the 3 things that they're going to be looking for. So section 1 is scored as follows. It's essential if you provide the correct numerical answer as a decimal or a fraction. Give yourself an E or an I or a P right now on your paper, right in the margin. E, P, or I. I want to see what everybody got on part A. E, P, or I. Most of you should have gotten E's. Do you agree? All you had to do is provide a proportion. Okay? So partially if you provided the correct numerical answer as a decimal but does not show the fraction that produced the answer, or shows a fraction with the correct numerical numerator but incorrect denominator, or shows a correct fraction but computes an incorrect answer. So if you do the correct decimal without the fraction, apparently it only gives you a P here. So we've answered our question, haven't we? If it's asking you for a proportion, guess what you should do? Write it as a fraction. Okay? Okay. And I, obviously, if you don't do either. Okay? Good.
so does that mean we have to do it as a decimal too then?
No. Fraction only is perfect. Okay? But if you did decimal only, then it's a P. That's what they're telling me. It's not showing me that you knew what you were dividing by, I guess, showing the work. All right, section 2. Remember, there's 4 sections on how this is graded. I want you to look on your paper and decide if it's an E, a P, or an I. Okay? It's essentially correct if the response identifies a 1-sample T interval. You've either wrote that, name or formula, and checks the conditions. I doubt many of us got an E here. Anybody check both the conditions and write the formula out? Guess what we're going to do from now on? Always do that. Okay? So let's go ahead and hear. Notice what they say, and I think these are interesting points. Any reasonable comment about the normality displayed in the stem and leaf plot is acceptable. So as long as you said the stem and leaf plot shows that it's nearly normal. Done. Check. You've met the condition. Okay? So they're not real specific about it, which is nice. But they want you to show me that you checked it. Yes, yes. That's in any case. If they provide you with a data display, use it. I do too. You don't have. Very rarely will they have you create one on your own. Okay. It's more about interpreting what's given to you. Okay. So most of us are probably in the P or the I on this particular section. It's partially correct if you identified the correct procedure and checks one of the two conditions. Or you don't identify the procedure, but you check both conditions. So if you didn't check conditions at all, which I think that's most of us, you have an I on section 2. So probably I for section 2. So to section 2I, because you didn't check your conditions, right? So if I were you, if you were keeping it, because you should probably be keeping all of these as we go through them as kind of a review, maybe make a little section in your binder or something for AP exam review and put these in. Write section 1, 2, 3, and 4, section 1E, section 2. Write why you got an I. You got an I because you didn't check conditions. Okay? And you name your procedure? I don't know. Section 3 is scored the following way. It's an E if you gave the correct confidence interval. Supporting work is not required. Notice if you just put down what the calculator gave you, then you got an E. The formula and just a plain old formula, the conditions, and the correct confidence interval from what the calculator spits out at you is enough. I know. I want to so bad when I'm grading them. I'm like, yes, good job. I can't write that, of course, but yes. Notice what they do say. If you put incorrect work in there, I have to mark down. But you have to write the formula. Okay? And that's in this case. It depends on what they're looking for, so I hate that you should have the correct work. Okay? Partially correct if you give an incorrect but reasonable confidence interval with an appropriate supporting worker shown. In other words, if you use Z procedures rather than T procedures, then we could possibly give you a P here. It's a reasonable one. Does that make sense? So that's something that you can think about. A confidence interval with incorrect supporting work. Okay? Note, if the response identifies a one sample Z interval as the correct procedure in section 2, then we get a P in section 3. I think that's what I just said, right? If you identify the wrong test but use it correctly, then you get an I and a P. All right, then I if you just did it wrong. Okay? All right, let's look at section 4. So section 4, we're looking at an E, a P, or an I. So if your interpretation of the interval should talk about estimating a mean, okay, inference about a population, our 95% confidence, and the context. We are 95% confident that the true mean lead level of crows is between blah, 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 and blah, blah, blah. That sentence covers all of it. Okay? You have to reference the true average lead level. That's what a confidence interval is doing. It's capturing the parameter, isn't it? That would be an E. Partial if you only did some of those things. To make a decision, did you on section 4 in your interpretation, did you cover all 4 of those things? Give yourself an E, a P, or an I. On your paper, you should have 4 different letters, E, P, or I. You can have E, 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 P, I, whatever. 4 of them. Find all 4. Okay? 4 letters. E, E, P, I, whatever it is. Okay? Make a decision. We good? When I grade these, I literally have to look for section. I make like little charts on my paper, and I write E, E, P, I. E, 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 and I have to write them down for every student that I grade, and then I have to decide if they have E, E, P, I, what number is that? That's what I have to score them. I'll show you what that means. Devin. Of A or section 1? Oh, A? You mean the question A? Or it's just asking a different question about the data. Okay, they don't ask you to put that in there in the confidence interval. They're not related, and sometimes they're not. Okay. All right. So how does the question itself get scored as a numerical value? So we've broken it down into E's, P's, and I's, and then we can go ahead and look here. In this particular question, each E counts as 1 point, and each P counts as half a point. All questions 1 through 5 get a score 1, 2, 3, or 4. Okay? Or 0. Could have a 0. If you get a 0.5, it does round up to a 1. Lucky you. Okay? So, oh, well, I'll tell you that in a minute. But 1, 2, or 3, or 4, give yourself a grade. Okay? Put it right at the top and circle it. What grade did you get? 1, 2, 3, or 4 based on this question? If you got a 2.5 or a 3.5, what does that mean? Down here, the grader, the individual person who's grading your AP exam has to use what's called a holistic approach and make a decision as to whether you go up or whether you go down. So if you didn't use a formula and you didn't show enough work or you didn't interpret or I don't think you demonstrated enough knowledge to me, I'm going to score you back down to a 2. But if you showed me work and were interpreting and used the correct statistical language, I will make you go up. Does that make sense? If you're in between, we get to make that decision. And not just Mrs. Macker. Like there's a whole, like we have a table leader, we have a section leader, and all different people get to read these tests too. Questions, Hunter? What, baby? Sure. What'd you guys get? How well did you do? 3s, 2s, 1s, 0s? Let's see. Did anybody get a 3.5 out of curiosity? Anyone close? No, you have to. No, count. What was your EEP or I? What was it?
I had E, I, E.
So you had 3 E's. That's a 3. Okay, so you got a 3. Anybody else not sure how to grade their EEPI stuff? So 3 looks. It was 3 the highest score on this particular question. And why was it? Because what did we forget to do? Conditions, right? Mm-hmm. But this 1, 2, 3, or 4 is what every question is graded on. Okay, so we'll practice this each day as we continue on. All right, save this piece of paper because on the back is another question that we're going to do on Friday. So don't do it ahead of time. All right, just put it in your binder, put it away. We'll look at this next question on Friday. Okay? All right, we'll practice these as we go forth. All right, let's talk about homework now, can we? Get your homework out. All right, so I graded for homework, by the way, question 26, and I was looking at the p-value, and only Isaiah got the right p-value, so I think we should probably go over 26, okay? So definitely look at that question. The odd ones you could have looked at in the back of the book, but question 16, let me just read you the answers real quick. For 16, the interval was 709.9 to 802.5. Okay, can I look at that just before? I don't want you to get, because we've all said the whole AP statistics community has gone away from the charts. Let me just guarantee before you continue to use them that you're given the charts, especially T. I know you are for Z's. I just want to guarantee. So let me double check that for you before you continue to use them. All right, remind me to do that. All right, on Friday. I don't have time today, but I will on Friday. Okay. All right. Obviously, we're gonna do 26. How'd we do on 16? Did you get it? Good. Did you? You did? Okay. So only 26. All right, let's do it. So 26 talks about a fuel company with a large fleet of cars. That large fleet of cars is probably something that we want to keep in the back of our mind because that might have to do something with sample size. We want to make sure to try to keep gasoline costs down, and we set a goal of attaining a fleet of 26 miles per gallon as our average gallon consumption. Okay, that's our goal. To see if this goal is being met, they check gasoline usage for 50 company trips and find a mean of that sample to be 25.02. Okay, with the standard deviation of that sample to be 4.83 miles per gallon. And it says, is there strong evidence that they failed to attain their goal? Okay, so this was actually something that a lot of us missed on the quiz, and as soon as we're done with this question, we're going to look at our quiz as well, because it has to do with the hypotheses and what are they and all of that, because there were some issues there too. So if look at question 2, we want to make sure that we're writing the correct hypotheses. And what would they be in this case? Tanner, eyeballs up. Open. If you need to come sit in the front row so you're not leaning against the back table sleeping, that's perfectly acceptable. Okay? So what is the parameter that I'm using here? When I say the word parameter, what am I even talking about, Judith? The parameter is, let's take a step back. What's a parameter? It's whatever, something about the population. In this case, is it a mean or is it a proportion? Mean. So the parameter in this case would be mu, the population mean. So our null hypothesis, and I still saw several of us not do this on their most recent quiz, should almost always be an equal sign. Okay? And we're thinking that the status quo is the claim is what? 26. So that would be the numerical hypothesis. What would the context version of that be? The mean average for our fleet of cars is 26 miles per gallon. Okay? You could say that. The goal is being met. And that's even better context, quite frankly. Okay? What's the alternative? Is it a one-tailed or a two-tailed test? Let me read the question again, because isn't there wording in the question that helps us make that decision? All right, so 26 says, is this strong evidence that they failed to meet their goal? So I love what Charlie just said. He said, could I say in the null hypothesis that the goal has been met? So the alternative is that they didn't meet their goal. Is that a two-tailed or a one-tailed test? It's one-tailed. It means that mu is less than 26. They didn't attain their goal. They didn't get their miles per gallon high enough. Okay? Some people think doesn't meet their goal means not equal to. And that doesn't happen in this case. It does mean less than. Are we okay with the context here? Now I'm going to go ahead and write what you said. The goal has been met. Goal has not been achieved. Yep. Yes, assumptions and conditions are the same things. And does it say to assume that assumptions have been satisfied? It doesn't? Oh, what are they? Okay. I will say that sometimes on the AP exam, it does say that in the question. If it says to assume the assumptions have been satisfied, you don't have to check them. Okay? So look for that. But it didn't say that in the last question we did. So we had to check them. All right, so here we're going to check our conditions. We've put our hypotheses out here. What are our conditions? The first one is, it doesn't say a random sample, I don't believe. Does it? No, chosen at random. Does. Okay. So it is a random sample. If it didn't say a random sample, we would have to assume that our sample is a representative. But if it says random, we've already made it. We're good. All right, second condition. Our sample size is less than 10% of all car trips, right? Okay, and the third condition is the nearly normal condition. I'm looking at our sample size. Am I in that zone where I have to check? Remember, less than 15, I have to proceed with caution no matter what, right? I have to be told that's normal. Between 15 and 30, I have to check and see if it's normal or not. I'm looking at unimodal and symmetric. I'm turning that stem and leaf plot on its side. Right, Sammy?
Yes.
That's right. Okay. Y'all better wake up. Question.
So this 20 trips,
So how would I check if it was 20 trips? Without a given stem and leaf plot, I couldn't. Okay? I would have to. But because it's so big, I don't have to worry about it. But you still need to say it. We're going to say 50 is, whoa, we're going to say 50 is large enough, so it's met the nearly normal condition. Why do I keep doing this? All right. So 50, we can say is greater than 30 if you want to say that. That's fine. 50 is greater than 30. Therefore, the nearly normal condition has been met. Perfect. Love it. We've checked our conditions. What's the next step? Finding our test statistic. Before I can do that, I have to find my standard error, right? So let's do that next. So our standard error is what? Well, it's our given standard deviation divided by the square root of the sample size, right? That's the new formula for means. So in this case, it is, it doesn't tell me. Somebody tell me what it is. 0.663? 683? Great. I do believe one of the questions in one of the parts A, B, C, or D says describe the sampling distribution model of a mean fuel economy for samples like this. What do they mean? Describe a model. Well, no. Well, sort of. Yes. When we're describing a model, we are talking about shape, what else? Spread, center, all that, right? Remember when it was a normal model, we could have described it like this: normal with a center of a mean of 3 and a standard deviation of 0.25. I don't know, whatever. Remember that? Normal described the shape. That was the center, and that was the standard deviation. Do you remember that notation? Well, we can use the same notation for t-distributions as well. So to answer that question, to describe the model, what they mean is this. We're going to use t's. We know with t-distribution that they are unimodal and symmetric, so that's describing shape. We're going to be specific, though, and we're going to say that we're going to use this specific t model because we're going to use the 49 degrees of freedom. Okay? Remember, the degree of freedom tells me which one we're looking for. And then we're going to put our center and spread. Okay? So the center was 25.02. And our spread was 4.83. No, it's not. I'm a liar. 6.683. Right? Yeah. Oh, and I'm sorry. It's actually, they got 26. Why did they do 26 is my question. Oh, hang on. The 26 is the claim. That's why. That's your center. If you're going to graph it right, that's going to be your center. So 26 goes here, and your standard error is 0.683. Okay? Zachary, did you put it on my desk? Thanks. It did it here. Oh, for 25, it was weird? 25, it was 23.3, which is the claim. And then the same thing, s divided by the square root of 40. Oh, I don't really know. I'm just telling you, I would accept that. Okay? That's describing the model. We okay with that? Kyle, does that make sense? Perfect. That's what I would. I would write that too. Tanner? Next time I tell your name, you're coming up here. All right, so where are we? Found the standard error. We need to find the test statistic. The test statistic is found by doing what? Your calculated average, your statistic, which in this case is 25.02, minus the claim divided by our standard error. It's always your calculated statistic minus your parameter, your claim, divided by. And Kyle, you know what sometimes I do to help me remember that, quite frankly, is on your formula sheet, this is given to you, right? And we know that's a statistic. So that's my calculated one.
Well, I know that's good. I did it right first.
Okay.
Whenever I had to
Okay, well, it should be negative, right? Because it's less. Let me tell you, let's see what the book got. They got negative 1.43.
Yeah.
Does that look right?
Yeah.
Okay. So if I'm going to, and you always should, draw this, we are going to shade less. When we're talking about t's, because of the degree of freedom, I have to draw my picture with the t's, with the test statistic values, the standardized values. My p-value is found not by normal CDF, but t-CDF. And it's your lower bound, your upper bound, and your degree of freedom, right? Double check me, but I believe that the p-value here is 0.079. Some of you were getting things like 88%, like a big p-value.
literally did it like backwards. That's all. Because I just did 1 minus what I got.
Very rarely will your p-value be really that large. So if it's that large, something was wrong. Most often, not always, but most often your p-value is going to be sort of close to being small, right? At least hopefully. So is our p-value small enough? And some people are still getting this part wrong. Can I reject the null or not?
No.
No. If it's not small enough, I'm going to fail to reject the null, which means what? In context. Look at our null context. I can't reject that. So what am I saying in context? Our goal's been met. I don't know. Let me read what they say. So E says, state what the p-value means in context. No, p-value in context means the likelihood of our sample happening by chance is about 7.9%. Part E would be the conclusion, which is what I read. The goal has been met. Do you feel a little bit better going through it again? Yes? Okay. So we have two things. One, I'd like to go, go ahead, question?
When it has the goal, will it be like 99% of the time, I can't say always, will it 99% of the time be a less than situation when it's not being met?
Yes, if it has not been met, that means you haven't gotten up to that goal. That is correct. It's the wording of the question, yeah. Speaking of that, I'm going to hand back your quizzes, okay? And I want to look at how your hypotheses were written, because almost all of you wrote your hypotheses wrong on the quiz, okay? So let me hand these back. All right, so on this quiz, the hypotheses are, one is that the condition, this is proportions, by the way. This is the two proportion Z tests, and we're doing the interval at the bottom as well. This is on chapter 22. But the null hypothesis was that the proportion of readers in Canada equals the proportion of readers in Britain. There should be no hats on those because we're talking about parameters, right? The alternative hypothesis is where almost everybody got it wrong. Almost everybody. Okay? It says Does the results confirm a higher reading rate in Canada? That means the proportion of Canadians that read is bigger than the proportions of Britons that read. It said that in the problem. Almost all of you did a two-tailed test. I'm not sure why. Tell me why you did it so I know. Yes. Right. Do we understand that mistake though? Like, do we can correct it at this point? We don't understand why that's true? Tell me, Sean. Where'd I lose you? Because the last sentence of the question says, do the results confirm a higher reading rate in Canada? Meaning that it's higher in Canada than it is in Britain. So the greater than sign, the bigger number, like higher in Canada. Right? So like think back to like the alligator eats the bigger number. Remember that? Right? I did too. I still do it in my head. Yes. Jordan. Why is what? The null is almost always equal to. The claim is that there's no difference between them. No difference between them would be the proportions are the same. Canada minus Britain equals 0. You could say that. But with a two-sample inference, that is always your null hypothesis. The other way to write that is this. Either of those are the only two acceptable null hypotheses. Okay? Just period. That's just what it is. There's, one or the other. Now, some of you wrote 1 and 2 here, which is fine as long as you do what Hunter did. And Hunter said at the very top of his paper, I believe it was you, Hunter, 1 is the proportion of Canadians and 2 is Britons. That's fine. But if you wrote 1 and 2 without telling me who was what, how am I supposed to know what you did? Right? Just be specific. PCB asked me to. I did that. That's fine. But 1s and 2s are fine as long as you're clear. Okay?
If you write like C and D on the
That's okay.
I wrote a key. I don't know if that was applied.
But you should write it. You should. But Kyle, you should write a sentence after each one. Okay, that's fine then. That's good. That's fine. Okay. The other common mistake that I saw is that people didn't pool correctly. So can I show you what the pooled p-hat would look like? So the p-hat pooled looked like this. It was 1009 plus 1004 because those were the sample sizes along the bottom. Now, because the question gave us percentages, 86% and 81%, we had to actually, find 86% of 1004 and find 81% of 1009. And those are not exact numbers. So we had to kind of round or truncate and kind of give me a whole number here. That was another common mistake. So I got 863 and 817 as the two numbers I would use here. When you're pooled p-hat. Because that's like x over n. Remember on the calculator, that's what it's asking you for is x and n, and the calculator doesn't like if you give a decimal number there. So it makes you round. That's why. Okay? And so your pooled p-hat, once you figured that out, as a decimal is okay, was 0.835. Okay? The conditions had to have been checked. I was looking for each of the 3 conditions. Several of you wrote that the samples were each representative, which is okay, but it says in the problem they were randomly sampled, right? And another thing that people are getting lazy about with the conditions is people were saying this. 86% of 1004 is greater than 10. And I wrote, multiply that out. Tell me what number that is. Don't make me do your math. Okay? Just lazy, that's all. Jordan. Just the answers, okay? All right. Some people forgot to the test statistic, which was a little over 3. 3.03, 3.01, 3.02. As long as you put it, either way, I would accept any of those. Something else people forgot to do, drawing it. Okay, we are looking for a z-score of 3.03. We're looking for the Canadians to be greater. Now, if you did this the reverse way and you did Britons was less than Canadians, and you did your hypotheses that way, then your z-score would be negative, which means you'd be over here. That's okay. You still get the same p-value. 4 was too big, yeah. Now, p-value, here's another common mistake. How do I find this? This is normal CDF because this is proportions, right? So it is normal, not T. Z procedures, not T procedures. Between our z-score, you know what? If you're using a z-score, that should be a 1. Hang on. Oh, hang on. Let me think this through before you tell me I'm wrong when I'm saying you're right. There are, so I think on a lot of your tests, if you use 3 here, then you should have a 0 and a 1. So I should be giving some of you a point back, I believe, right? Because that's a z-score, so you should assume 0 and 1. If you use the test statistic, not the test statistic, if you use your percentages, your p-hat, 0.835, that's when you should have changed your standard error here. Okay? So on quite a few of yours, I'm going to go back and check that on everybody's paper, so if I could have them all back, I'm talking myself through it. If you did this, then 1 is acceptable because it's a z-score, right? So you should have a 1 there. When I was grading it, I was looking for the standard error to be there, but that's only if you use this value, the p's, the p-hats versus your p. Okay? So that's my mistake. So I want to give some points back. So before you leave, give them back to me so I can look at that again. Okay? Yeah, because I took a point off if people put 1 there. That was my mistake in grading. I think I circled 1, right? If I circled your 1, I'm giving you a point back, period, basically is what I'm trying to tell you. As long as you have have your right z-score here. Okay? You've got to have the z-score correct here. All right? Okay, I'm just talking my way through that. I was just thinking about that. I'm like, that should be a 1 if it's a z-score. Anyway, your p-value was pretty close to 0. And some people wrote equals 0. Please use a wavy equals, okay? I know your calculator said 0 in some cases, but it's approximately equal 0, approximately 0. And you would definitely reject the null hypothesis because you have a really small p-value. And you would say in context, we have evidence to suggest that Canadians have a higher reading rate than Britons. By the way, I had no idea that's why you spelled Britain. That made me crazy. I don't like that. I thought it was B-R-I-T-T-A-I-N or something like that. Anyway, Britons. What? Okay, give me a minute. Let me finish going over it and I'll look at your specific, okay? All right. Question on the first part, and then we'll come back. And yes, I'll look at yours individually in a minute. You have to say you reject the null. You have to say that. They are looking for, I graded a hypothesis test question last year, and that was part of the grading rubric. That was, you didn't get an E on that section unless you said the words reject the null. And accept the whatever, it was actually failed to reject the null, and on my grading rubric, if it said accept the null, you had to mark it wrong. Yeah. There, you cannot accept anything. They made me not get any E's for that. Just saying. Okay? Yes. Reject H-O. Yes. Ho. Perfect. All right. Now let's go to the bottom part, and then I'll go back to individual questions. Okay? So on the bottom part, it says find a 99% confidence interval for the difference of proportions. Interpret your interval. We've already checked the conditions. We did that at the beginning, so there was no need to do it again. Okay? But as we learned from the OPQ that we did, or OPQ, FRQ that we did, if we hadn't, we should have, right? The formula I was looking for, because not often have we done 99% confidence intervals, so you had to find a new T. I'm sorry, it was a Z, it's a means, right? So you had to do inverse norm of 0.995, and you should have found your new Z star or your critical Z value to be 2.576. Some people just wrote 2.58. That's okay, but you just had to round properly. And then you would use your standard deviation, the pooled standard deviation from above. That would have been fine. And you could have just produced what the calculator told you, and that would have been fine. Here's where I took off some points. Some people told me something like this. I'm not calling anybody out, but I'm just kind of remembering what some of the interpretations of the interval were. Both Canadians and Britons read between 0.75 and 9.25%. Gosh, I hope they read at a higher percentage than that. That means like the whole country is illiterate, right? So that would be terrible. So definitely not that interpretation. Some people said 0's not in the interval. Done. Well, that's great, but what does that mean? Okay, I'm glad you're looking for 0 to be in the interval, but what is the interpretation of 0 not being in the interval? What does that mean? So really what I would like you to say is, we are 95% confident that the true proportion of the difference between Britons and Canadians who read is between 0.75 and 9.25%. Some people, and I have to say even more, not only is that there's that difference, you have to tell me who reads more. Well, because we put the alternative hypothesis that Canadians went first, then my confidence interval was positive, then that means Canadians read more. Now, someone did it backwards, and they had negative, and that was okay, because they said Britons and Canadians and did it backwards, and their confidence interval was negative at the same values. I don't know who you are, but that was fine. Okay? I didn't take off for that. Did you have a question, Charlie?
I was just saying that I said that Canadians read the numbers more than Britons do. That's basically
Same thing. Yep. We are 95% confident that.
Yes, that's what I wrote.
Okay. Yes, true. True. Yes. Oh, 99, sorry. Yes. I'm so used to saying 95. Anything else, question-wise? No? Okay. Then I'm going to hand out your investigative task. Okay? You're going to start on it today, and we're going to finish it on Friday after we talk about two-sample inference with means.
Are we ever going to go over
Yes. All right. So I'm giving you some information, okay? And it's a lot if you open it up. And it is the verbal and math scores for a specific high school. And I give you the gender and the verbal and math score for that particular group of people, okay? So you're going to do a couple of things. Tonight, or before Friday, you're going to actually do parts 1 and 2. Okay? Let's do that again. You're going to see how there's 1, 2, 3, 4 up here? You're going to do 1 and 2 before Friday. You with me? We don't know how to do 3 and 4 yet. We will after Friday. Okay? So together, it's one big investigative task. We're just going to do it in parts. Fair enough? Okay. So for number 1, what is the mean SAT score at this high school? You can figure that out, right? It might take a second, but it's not going to take you that long. Use your calculator. You got it. Now, number 2, how do these students' SAT math scores stack up against the rest of the state? So what we're going to have to do is we're going to have to kind of look at and decide. So let's keep reading. It says, you have a copy of the data from the SAT score roster sent to the high school by the College Board. It shows verbal, math, whatever, for 303 students in a recent graduating class. Note, you will not use all of this data. Just use a sample of 20 to 30 students. That means that the information that I do is going to be different than the information that Daniel does, which is going to be different than the information Evie does, because you're not all going to collect the same sample, right? No, you're not going to do that. Okay? But you do need to explain your randomization procedure. Okay? And I think, should we all agree on 20 or 30? Let's pick one. 20? Well, we have to make a decision because out of 303 students, our sample size can't be larger than 10%, right? And it has to be, that's really the only condition we have to worry about, and nearly normal, but that's if our sample is nearly normal. Well, because what we'd have to do, in order to meet the nearly normal condition, we would take our, if we did 20, we would take our 20, and doesn't 20 lie in that strange range between 15 and 30? And you would have to graph the 20 and see if they're nearly normal. If we choose 30, do we even have to do that? Do you see my point? If 25 is in that in that medium range, 25, again, you'd have to check the nearly normal condition. 30, any 30 or higher, you've met it. So I think 30 makes more sense to me. So you don't have to draw a histogram of your samples, but that's just me. So let's all agree on 30. Can we do that? Okay. Describe your sampling procedure. Do me a favor and highlight on your table. You will turn this in with your investigative task. Highlight the 30 you picked, because I'm going to have my aide double check that y'all found the mean right. Okay? It's just plugging into a calculator and adding and dividing by 30. It's really not that hard, right? But you can do it. I know you can. I have confidence in your AP statistics abilities. You can find the average. All right. And right now we're only worrying about math scores, right? That's all parts 1 and 2 are dealing with. It's math. Math only. But it's important to keep your sample highlighted because you're going to reuse the same sample for parts 3 and 4. Okay? Do not lose this. All right, so for part 2, it says how do these SAT math scores stack up against the rest of the state? If you look at the little bullet points towards the bottom, it tells you what the state math mean score, or the state score is, doesn't it? It says it's 503. So 503 we will treat as our population parameter. That's our claim. You're doing a hypothesis test for number 2. Okay? Any questions? No? Okay. So that's your homework. All right? For parts 1 and 2, you're going to do this. And that's all I'm going to have you guys do for homework. Okay? Perfect. And Amanda, you can do it when you get back because it's only going to go on quarter 4. So chillax. All right.